and we're also going to do the remaining problems we didn't do in the 2012 paper. That is the hard problems. Right. Okay, so Christine, what questions did you find challenging or interesting?
Question 17, 21, and 24.
Okay. And what question do you want to explain?
Question 10.
10? Okay. What about you, Franklin?
I found 22 and 24.
Okay. And what question are you going to explain?
Is 16 taken?
No.
Okay, then I'll explain 16.
All right. Great. So I'm just going to turn my video off, and I'm going to share the screen. Okay. So first off, we have question 10. Christine, could you please explain?
Yeah. The positive integers x, y, and z satisfy x times y is 14, y times z is 10, and z times x is 35. What is the value of x plus y plus z? So the first one, x times y equals 14. There's only two positive integers that could equal 14, which is 2 times 7. And next we see y times z is 10. And for the first one is x times y, which means it's 2 times 7. And in the second one, there's another y, so that y is 2. And 10 divided by 2 is 5, so 2 times 5 is 10. And the last one, z times x is 35, which is 5 times 7 is 35. So x plus y plus z is 2 plus 5 plus 7, which is 14.
Okay, great. All right, next up, we have question 16, Franklin.
Oh, okay. So question 16 is asking us, it's asking us the sides of a rectangle ABCD are parallel to coordinate ABCD lies below the x-axis and to the right of the y-axis. As shown in the figure, the coordinates of the 4 points ABC and D are all integers. For each of these points, we calculate y-coordinate divided by x-coordinate. Which of the 4 points gives us the least value? So we want x to be as close as possible to y. So then it's A.
A? Wait, you
Yeah.
said x close as possible to y. Could you elaborate?
Okay, let's say I have number 16. Yes?
Yeah, okay.
The number is going to be less if I have 16 divided by 4 than if I have 16 divided by 2, right? And
Yeah.
14 is closer than 2 to 16, I guess you could say. But 8 is closer to 16 than both of them, and it would be less than both of them, therefore.
Oh, okay. So which of the 4 points gives the least value? Right. Yeah, that's a way that we could do it, but you have to also consider, like, if it was 8 over 16 or something like that. But like, and also, just to note, it's okay if you didn't find this because like you don't see it at first, that this is actually below the x-axis and to the right of the y-axis. So how does that impact the answer? So if we look, if it was two positive integers, which means, for example, the coordinate was x, y, okay, and they were both positive, that means y divided by x. And if we want to find the least value of y divided by x, We want x to be as large as possible, and we want y to be as small as possible. Because, for example, if we have the number 1 over 1, 2 over 1, dot, dot, dot. So when y becomes bigger, as y goes to, like, as y approaches infinity, y divided by x also approaches infinity. And when x approaches infinity, y divided by x approaches 0. So that means basically the larger x is, the smaller y divided by x is. Because, for example, we have 1 over 2, 1 over 3, and dot, dot, dot. So this is in a positive axis. And it's quite different from the positive and the negative axis. So what if there was 1 in the negative axis? So we have the x is still positive because this side is the positive x, this side is the negative. So we have x negative y. Let's just say that. All right, so let's just say that x and y are positive numbers again. So then this way we know that the y coordinate is a negative and the x coordinate is a positive. So then we get negative y divided by x, which equals negative y over x. Which means that since we have the negative sign, the larger y over x is, the smaller the number is, because since it's negative. Which means that we want to maximize this value. So we want y to be as large as possible and x to be as small as possible. So this is what we want over here. We want the negative y to be as we want negative y to be as large as possible, because like down here, if we're actually talking about the coordinates, for example, we have x1, y1. Then that means like this point is x1, y1. x1 is a positive number. y1 is a negative number. And since we want the y in here to be as large as possible, it means that you want negative y1 to be as large as possible. So that means if we want negative y1 to be as large as possible, it's going to be either point A or point B. Because negative is basically the negative of a y value is basically the reflection of x-axis. So that means like if we make the y value negative, so if we have point x1 negative y1, it's going to be here. It's going to be reflected through the axis. So then we figured out that it's either going to be A or it's going to be B. So now x1. We want x1 to be as small as possible, which means that A is as small as possible. So that means the answer is A. A for A. Okay, yeah. All right. Do you guys understand?
Yeah.
Okay. Now question 17. All 4-digit positive integers with the same 4 digits as in the number 2013 are written on the blackboard in an increasing order. What is the largest possible difference between two adjacent numbers on the blackboard? All right. Okay, so that means so for all the combinations possible, it can only be 1,000 something, 2,000 something, and 3,000 something. We have many combinations of 1,000 something. So like, for example, we have 1023, 1032. We see that the difference is in tens. What I mean by that is like, so 1032 minus 1023 is equal to 9. And 9 is basically, it's really close to 10. So we say it's on the levels of 10. The magnitude is different. All right, so now after we have 10232, we have 1230. No, 1203. So we see that there's the 0 and there's the 2. So the difference is on the order of hundreds, which is basically like the difference is n times 100. Kind of like that. So now we know that. Let's just continue. So we have 1203, 1, 2. If we swap the 0 and the 3 around, then the difference, the order of the difference is in tens, which means that the difference is like something 10. And then after that, we have so 1, 2, 3, 0, and then we have 1, 3, 2, 0, and then we have no 0, 2, we have 1, 3, 2, 0, and then we go to the twos. So first off, so the first 2 is going to be 2013. The difference from 1320 to 2013 is a large jump from 1032 to 1203. Although they're still in the order of hundreds, there's still quite a big difference. See, this is almost 200 of a difference, but this is like 700. So then we see that if we're going to go by the order of hundreds, then we see that it could be like 20 something something, it jumps to 21 something something, jumps to 23 something something, which means that the maximum difference is going to be around 200 if we're going to keep the same thousands. So we don't want to keep the same thousands, which means we want to see the gap between the thousands. So the first one we have is 1320 all the way to 2013. So after 1320, then we have the number 2013. Then we have dot dot dot, a lot of other numbers. And then to the next, so then to the last 2000, we have 2310. So now we take the jump to the 3000s. So we have 3012. So we see two differences that are pretty large. 2013 minus 1320 and 3012 minus 2310. So all we need to do is calculate it. 2013 minus 1320 is 693. 3012 minus 2310 equals 702. The 702 is the largest difference. So the largest possible difference between the two adjacent numbers on the blackboard is 702. All right. Now, what question are we on? We are on to question 21. In a crypt arithmetic puzzle, different letters represent different digits and the same letter always stands for the same digit. Given that the equality of the puzzle BDCE plus BDAE equals AECBE holds, what digit does the letter D represent? Okay, so we have the word BDCE, or I should say number, and then BDAE, and then we get AECBE. All right, so we look at this, and we're going to have to find some sort of pattern. Not pattern. We're going to have to find some relations that we can easily figure out what some numbers are. So for example, first off, we have E plus E equals NE. But we know that the maximum value of a digit plus itself is equal to 18, which means that n can only equal 1 or 0. So let's say E plus E equals E. Then that means E equals 0. Now what about if it was 1? So E plus E equals 1E. I don't think that's possible unless E is 10. But if E was 10, then that won't make sense because E is only a digit from 0 to 9. So that means E has to be 0. So we can substitute the E out. And then, let's see, what do we have? All right, then we have B plus B equals something 0. As we said earlier, two times a digit can have a maximum of 18, which means that there's no way this is a 20, the a is a 2. Because even if we did have like d plus a equals something, and then there was something carried over, the something has a maximum of 1, which means a equals 1. So a is 1. Wait, one sec. That was, what was that? That was a d. Okay. The a is a 1 now. Alright, so now let's look. B plus B. What does B have to be? B has to be 5, because you cannot carry a 2 over if it's just 2 digits added together. So B is 5. And now we only have a few things left. So then we get C plus 1 equals 5, and D plus D equals C. Alright, so let's see. First off, D plus D does equal C. It doesn't equal 10 plus C, because as we see here, we don't want to carry a 1 over to this column. So then now we know that D plus D equals C. Okay, so that's not too much use, is it? And now we can check C. So C plus 1 equals something 5. So 4 plus 1 equals 5. 14 plus 1 equals 15. But we know a digit can't be 14, so C equals 4. And that means D equals 2. Alright, do you guys understand?
Yeah.
Okay. And now question 22. In the 6 times 8 grid shown, 24 of the cells are not intersected by either diagonal. When the diagonals of a 6 times 10 grid are drawn, how many of the cells are not intersected by either diagonal? Okay, so first off, we see that it's 6 times 10, and then it's going to be something like this. So we see that if we split it into the middle, we get 4 3x5s. So each 3x5 is a 3x5, but it has a diagonal, just one diagonal going through the 3x5. So that means if we find out how many squares are not intersected by the diagonal inside each 3x5, then we can just multiply it by 4. Because like basically all the other 3x5s are exactly the same. Alright, so if we do that, there's 2 ways we could do this. We could either count, or we could use a mathematical way to calculate. So first off, we see that we start from this dot to this dot. And how many squares do we intersect? Well, if we travel on the line, see we touch an edge. Not an edge. We touch a line that is inside the square and the rectangle. And when we touch the line, we see that we exit out of the square. And if we touch another line again, we exit out of another square. And if we can keep touching the lines, then that means we'll keep exiting squares. Right. So it's like that. So now we know what the pattern is. Let's see. We find that like we know that since the line goes from one corner to the other corner, it's going to go through all the horizontal lines. So there's no, that's vertical lines. So go through all the vertical lines, 4 of them, plus all the horizontal lines, 2 of them. So then that means that we counted all the squares that have the line go through them. So when I mean go through them, I mean go through a side of the square and go out. Which means that, do we have all the squares that the line passes through? No, because if we have the corner square, the line does not pass through the corner. It just, let's just say it doesn't pass through the corner. just like it just goes to the corner, intersects it, but it doesn't pass through. Well, that doesn't really matter, but what matters is that when we exit out of this square, and we don't really exit anyways, then we have to pass one of these lines. But the line that it's going to intersect is not any of the lines we counted. So we have to count the far corner here. But what about this corner? Well, for this corner, you see, we can go through one of the vertical lines. So this is equal to 7. 7 squares passed. And then we do 15 squares minus 7 squares equals 8 squares, and 8 squares times 4 squares equals 32 squares. That has not had a line pass through them. Right, do you guys have any questions?
No.
What about you, Franklin?
No, not really.
Okay. All right. Now we're on to question 24. John chooses a 5-digit positive integer and deletes one of its digits to make a 4-digit number. The sum of this 4-digit number and the original 5-digit number is 52713. What is the sum of the digits of the original 5-digit number? So first off, looking at this number, we know it's going to be an A, B, C, D, E plus A, B, D, E, or whatever. Just delete one of the digits. We see that the number ends in 3. That means E plus something equals 3. But if E added itself, it will equal an even number. So that means the end cannot be a 3. So therefore, the digit that was deleted was E. So now we have the number puzzle, whatever you call it, the letter puzzle. Now we have to figure out what each letter is. So first off, we see A. A could be equal to 4 or 5. All right, so now we have B plus A equals 2. But we know that A is 4 or 5, so that regardless, that means B plus A equals 12. Since B plus A equals 12, we have to carry a 1, and 1 plus A equals 5. So therefore, A is equal to 4. Wait, let me just erase this, make it neater. Right, so A is equal to 4. So we can replace A and write 4. That means B plus 4 equals 12. Which means that B could equal 7 or 8. Because remember, C plus B could carry on a digit. And that's exactly what happens. It's the same case as what happened with A. You see C plus B, two digits that are different equals 0, which means that it must be 10 because only 0 plus 0 is equal to 0 for digits. And wait, it never said that B and C couldn't be the same. But we already know that B has to be 7 or 8. So that means B is 7. Since there will be one passed over. Okay, and then so it's 7. All right, and C. So C could equal 3 or that's it. So C equals 3. Because 3 plus 7 is 10. Oh. Okay. All right. So then we have 3 plus D equals, oh wait, one sec. So C could also equal 2 because like it's in the same case as before. There could be 1 carried over. And since D plus 3 equals something 1, then we know that there was something carried over because like 2 plus something can't equal 1 unless it's negative. And since we're talking about digits, no digit plus 2 is 1. So that means C is 2. And then we have D. So D plus 2 is 11. So D could either be 8 or 9. And in the cases as before, we see that D has to be 8 because there has to be something that's carried over, since E plus D is 3. So that means E has to be 5, because 5 plus 8 equals 13. So if we add them together, we get 2 plus 8 is 10, 4 plus 5 is 9, 9 plus 7 is 16. So 26. Wait, one sec. 26? Wait, wrong. Yes, I did something wrong. All right, so I'm just going to go over it and going to see. Oh my goodness. You guys know what I did wrong? I accidentally put a 0 here. This is 7. This is 7. So that means I just completely messed up. You can just forget what I said, except that A and B is equal to 7. All right. So now we're on the step with the C's. So starting over, we're on the step with the C's. So C plus a 7 equals 7. And wait, what? Oh yeah, so that means, and since there will be 1 carried over, that means C has to be equal to 9, because C cannot be equal to 10. So C equals 9. So D plus 9 equals something 1. And since it has to be carried over, since 9 plus 7 is 16, so we need an extra 1 to make it 17. So that means D equals 2. 2 plus 9 is 11. And then that means E has to equal 1. Because 1 plus 2 is 3. So then we get 4 plus 7 plus 9 plus 2 plus 1. 2 plus 1 plus 7 is 10. 10 plus 13 is 23. So the answer is 23. All right, do you guys have any questions?
No.
All right. Question 23. Recall. First off, do you guys know what a square, a cube, and a power is?
Yeah.
What about you, Franklin?
Yes.
Good. All right. So we don't need to read the intro. Let S be the number of perfect squares among the integers from 1 to 20. Wait, is it 2013 by the power of 6? So S is all the squares. And then Q be the number of cubes among them. And what is the relationship between S and Q? So first off, if S was the squares, then we would have 1 squared, 2 squared, 3 squared, dot, 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 all the way to what's the largest square they could be? Well, the largest square there could be in this list is 2013 by the power of 3, because this squared equals 2013 by the power of 6. Since it's the rule of the powers, or whatever it was called, if we have a by the power of b by the power of c, this equals a by the power of b times c. So that means this equals 2013 by the power of 6. All right. So now, going on, we have 1 squared, 2 squared, 3 squared, all the way to 2013 by the power of 3 squared, which means that there are 2013 by the power of 3 squares in the list, because like it's 1, 2, 3, 4, 5, 6, 7, 8, all the way to 2013 by the power of 3. So that's how many squares there are between 1 and 2013 by the power of 6. And now for q, we can basically do the same thing. So 1 by the power of 3, 2 by the power of 3, 3 by the power of 3, dot, 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 all the way to 2013 by the power of 2. So 2 times 3 is 6. So now it's asking for the relationship. S is not equal to q, so cross A out. 2s equals 3q. That's not true either, because okay, let's just write it out. Since this is 2013 by the power of 3, S equals 2013 times Q. Because 2013 by the power of 2 times another 2013 is equal to 2013 by the power of 3. So that means the answer is D. All right. Right. All right. Question 20. John has made a building of cubes standing on a 4x4 grid. The table here shows the number of cubes standing on each saw. When John looks from the back, what does he see? We have 4, 2, 3, 2, 2, 1, 3, 3, 2, 1, 3, 1, 2, 1, 2, 1. Okay. So it says when John looks from the back, what does he see? Well, so first off, he's going to see, like, if he's looking from the back, that means he can see, like, 4 columns of blocks. Since there are 4 columns and 4 rows of towers. Different towers of different heights. So first off, if John is looking at the back, that means then this is his left and this is his right. So this is his left and this is his right. So starting with the left. Okay, so we have 2, 2, 1, 2. The maximum height is 2. So he sees 2. And then 3, 1, 3, 1. The maximum height is 3. So he sees 3. 2, 3, 1, 2. Same thing. He sees 3. And then 4, 3, 2, 1. He sees a 4. So it's max height. So that means the answer is C. Francius says, on my 60th birthday, I got many presents, and I hope to get as many on my 80th. Each of my children has as many children of their own as siblings, and none has grandchildren yet. My age is now equal to the number of all my living descendants. How old is Francius? All right, so how do we solve this? We have to look at some conditions first. So he says, on my 60th birthday, I got many presents. So that's past tense, which means that Francius's age is larger or equal to 60, because his 60th birthday could have just passed. And I hope to get as many on my 80th, so that means his age is less than 80. And each of my children has as many children as their own siblings. So each of his children, so let's say he has C children, has as many children of their own as siblings. So that means C times C minus 1, because each child has C minus 1 children, and since there are C children, it's C times C minus 1. And then none has grandchildren yet. So except for him, none of his descendants have grandchildren yet. So that's all. My age is now equal to the number of all my living descendants. How old is Francius? So living descendants. So that means C plus C times C minus 1, which equals C squared. Can anybody tell me how I got from here to here? Okay, so first off, we see that there is a common, like, for example, if we have AB plus AC, it can be written as AB plus C. So a common multiplier. So c is a common multiplier here, which means that it's c times, since this is a c times 1, so it's 1, and it's a c times c minus 1, so plus c minus 1, so this equals c squared. Alright, so now we know that c squared is Francios's age, and Francios is between 68 years old and 80 years old. So that means c must equal 8. 8 times 8 is 64. So that means his age is 64. The diagram shows a shaded quadrilateral KLMN drawn on a grid. Each cell of the grid has sides of length 2. What is the area of KLMN? Okay, so I'm not going to draw the entire thing out because it'll take too much time. So we're just going to draw out the shape and some attributes of it. Just keep in mind that this side and this side aren't parallel. So how do we do this? Well, as you can see, we can draw some stuff around it. So this is a shaded shape. We don't necessarily need to calculate the shaded shape. I mean, you could calculate it, but like it's not that good of a way. So it's easier just to calculate the outside. It's this rectangle minus the unshaded shape because they're all like triangles, so it's easier. All right. So first off, we see that the units are all 4 centimeters. Yeah, it's centimeters squared. So that means we could do 4 times, and then we can just treat each unit as a unit. So 1 centimeter squared. So that means, first off, looking at the shape here, that's like not a triangle. It's a concave quadrilateral. Looks like this. All right, so first off, this is 4 units long. This is 1 unit, and this is a square, so 1 unit. And then this is 3 units long, which means the area of this shape is 1 unit, because of the square in the middle. And then 1 times 3 divided by 2, 3 over 2 plus 2. Oh, wait. Okay, yeah, we'll just do this first. And then we have this triangle here. So this triangle's units is 3 and 4. So that means 3 times 4 divided by 2 is 6. Area of a triangle. And then we have 1 and 7, I think, up here. So that means it's 7 over 2. And I should have wrote this earlier. I should have done the area of the entire rectangle minus this. But, you know, I'll do it right now. All right, and the area of the rectangle, it's 7 by 5 rectangle, so it's 35. 35 minus 1 minus 2 minus 6 minus 2 over 7 minus 2 over 3. So 2 over 7 plus 2 over 3 is 5. So minus 5. 1, 2, 6, and 5. So 1 plus 2 plus 6 plus 5 is 14. So 35 minus 14 equals 21. And then 21 times 4 equals 84. So the area of KLMN is 84 centimeters squared. And a key pointer of this problem was the 4 we multiplied. It's not 2, it's 4. For example, how many unit cubes fit in a 10 by 10 unit cube? Well, your first reaction may be, well, 10, because 1 times 10 equals 10. But no, it fits in 100 times. Because the area is 100, so 100 unit squares. Right. So do you guys have any questions? Is it a bad idea to the area. It's not necessarily bad if you can find a way to count it efficiently, and it's like faster than what I did. That's completely okay. So whatever works for you is okay. Just if you find like problems that if you find like problems that it's hard to count the area, then you could just calculate it. But this one, I think you could do the area. All right. Question 17. Anyways, that was a good question. All right, question 15. V wrote down several consecutive integers. Which of the following cannot be the percentage of odd numbers among them? So we have 40, 45, 48, 50, and 60. Let's see. All right, so first off, 50, if there was an even amount of consecutive integers, then it's going to be a 50-50 split between odd integers and even integers. So we can cross that one out. And then if there's if there could be 40% of consecutive integers that are odd, there could be 60% because one is the opposite of the other. So for example, if we have like the odd numbers, it's 60%, and the even numbers, it's 40%. They can interchange because we know always that if it's several consecutive integers, that means there it would be always one number, one of the types, even or odd, more than the other type. So for example, if we have 1, 2, 3, then there's only one even and two odds. And but then we can also do 2, 3, 4. So then it's two evens and one odd, which means that like the amount of numbers uh, in several consecutive integers can be interchangeable, which means that if we have 40% and 60% as an answer, then we can flip them around. So this is just a shortcut for when you're doing a contest and you have limited time. But if you don't have limited time or the contest doesn't give you multiple choice, then you have to use a uh, equation to calculate which one doesn't work. All right. Huh? That's weird. All right. So now, we can just cross out 50, 40, and 60 because it's basically the same idea. If we do the equation way. So we'll look at 45 and 48. But first off, before we start, okay, we know that if it's not a 50% split, then we know that there is an odd number of consecutive integers. So if it was 45% odd or 48% odd, then there's going to be one less odd. So odd, the amount of odd is, let's say this is n consecutive numbers, the amount of odd is n minus 1 divided by 2, and the amount of even is n plus 1 divided by 2. Yeah, all right. So looking at this, and we also need to know the percentage. So then that means it's the percentage of odds are n minus 1 divided by 2 divided by n. Or you could do n plus 1 divided by 2 divided by n because, as I said earlier, they are interchangeable, which means that if you calculate the evens now, it is possible that the evens turn into the amount of odds and the amount of odds turn into evens. What I mean by this is, for example, we have odd, even, odd. I mean, even, odd, even. So that means then we follow the n plus 1 divided by 2 for the evens. But then we could also have odd, even, odd. So if n plus 1 divided by 2 works, that means n minus 1 divided by 2 will also work. And if we just test the n plus 1 divided by 2, it could be for the evens or the odds. All right, but that's enough talking. Let's just stick with n minus 1 divided by 2 and then divide by n. So then this expression equals n minus 1 divided by 2n. So then this is a percentage. So I mean, this is a decimal or a fraction. It's not a percentage. So we have to we have to make 45 into a fraction. So then or a decimal, 45 over 100. So these two equal. All right, and now let's solve the question. I think it's easier to do it in decimal though, 0.45. So we have 2n times 0.45. So n minus 1 equals 2n times 0.45, which is 0.9n. And if we have 0.9n and n minus 1, then if we subtract 0.9n on each side and add 1 on each side, we get 0.1n equals 1. So n equals 10. So if n equals 10, then that means it's an even number of numbers in here. And since we stated that n must be an odd number, then that means 45% cannot be a percentage of odd numbers among them. And let's try 48%. So then we get 0.48, and this is 0.96n, and then if we subtract on each side, it will be 0.04n equals 1. So then n equals 25, and 25 is an odd number. So that means the answer is B, 45. All right. One of the following nets cannot be folded to form a cube. Which one? All right, so A, we have this thing. And then we have B, C, D, and E. All right, so first off, looking at A, we see that if we fold it up, like, use your brains, guys. Make space in your brain, and then use the space within to make, like, one of these nets and see if you can fold it up. So if we fold it up, it's going to be looking like this. So let's say this is the base. And then it's starting to fold up. So there's this here, there's this here, and then there's like this here, there's this here. And then there's also the top. And I won't draw the top. Well, anyways, so if you just use your brains and think about it, then you find out that you could fold A into the net of a cube. So now we can't just do this to every single one of them. We have to find a faster way to do it. So we see that if we fold a net of a cube up. So for example, it looks something like this. And we can fold this net up. Then we see that if, for example, we fold it up and it turns into something like a wheel, and there's like one of the flaps here and one of the flaps over there. Yeah, and then like, let's just say this is 3D, okay? All right, so if we folded it up, we can cut it at another point and then stick this point onto this point. So which means that we got something like this. So we can basically do the same thing with this figure, except we don't need to do it with A because we already determined that we could use A. So now it's B. For B, it looks like this. And then, so if we glue this end to this end and we cut off this end, then we get this. So now that we got this, all right, so if we fold it up, we see that if the triangles are in this form, in A, we saw that if the triangles are in this form, that means they fold up to be a square, and the same as these. All right, and then C. C is like this. So let's try and put the triangles in the same formation as in A. So what if, let's say, we like take off this part, glue this part onto here. Then what do we get? We get so right here we have this shape, this shape. Oh, okay. So it's like that shape. And then okay, wait, what direction is this shape? Like this. And then over here we have what do we have? Oh wait, one sec. That is not correct. All right. So first off, starting from the right, after we rearrange the figure, it's this square, and then we have this square, like this, and then we glue this one right beside this one. So then we get, flip this triangle around. So we get this, and flip this triangle around. So we get this. Yeah, I think. Right. Okay, and then after that, we have this. So we see that this is basically A, except two of the triangles are flipped around. But we see that this configuration, unlike A, if we put the two triangles beside each other in like this formation, then this cannot form a square. Oh, and since because like we can rearrange the net of a square so that any way we rearrange it in a certain way, then it can still be folded up as a square. But this way cannot be folded up as a square, which means that C is the answer, that it cannot be folded up into a cube. All right. So I think that I think that's enough questions for today. So now we're going to look at some more interesting questions. All right. So remember last time that we had like these very interesting questions? So first off, we have number 13, repairing a chain. Just letting you guys remember what it was. So do you know why the young craftsman blah 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 blah? So he has 5 short pieces of chain that must be joined into a long chain. Should he open ring 3? Link it to ring 4. So basically open this and then link it and then close it and then unfasten ring 6. So basically link 6 and 7 together and then so on. It will take 8 operations. So 8 opens or closes. But he wants to do it in 6. So how does he do it? So it's been 2 weeks now. I think it's appropriate for me to give the answer if you guys don't have the answer. So do you guys have any ideas? Any other ideas? Or do you just want me to show you guys the answer? Franklin?
Can you tell us the answer?
Okay, what about you, Franklin?
No.
You don't want the answer?
No, I want the answer. I don't want to give one though.
Oh, you don't want to give one. Okay. All right then. So the answer. So first off, you open chain 1, 2, and 3. So then you get a separate open chains. So then now you got open chains. You can chain chainlet 1. I'm just gonna call them chainlets. You chainlet 1 to 4, 5, 6, and 7, 8, 9. So then you get 7 in a row. So that's 4 operations because you opened all of them and then you closed one of them. And then you can do the same thing with chainlet 2. So then chainlet 2, you chain it to the long chain and 10, 11, 12. So then you get this. And then chainlet 3, you chain it to the long chain and 13, 14, and 15. So that's 6 operations. All right, and there was also question 17. 3 squares. Takes 8 small sticks, 4 of which are half the length of the other 4. Make 3 equal squares out of the 8 sticks. Do you guys want another week to think of this problem, or do you just want me to give the answer?
Can we have another week?
Okay. All right then. So, and let's see. Keep it even. And there's also keep it even. This one's also an interesting one. Take 16 objects and put them in 4 rows of 4 each. Remove 6, leaving an even number of objects in each row and in each column. So how do we do this? And it says that there are many solutions. So why don't we just try for a bit? We try for the solutions. All right, so first off, something that might help you think is that, see, we have 4 here, 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 4 here. And then, so if we remove an object, then this changes into 3, and this changes into 3. And then if we remove another object, this changes into 3, and this changes into 3. And then let's say we remove this object, this changes into 2, and this changes into 2. And then so we still have a 3 and a 3, so we could change that later. Maybe we want to cross this one out. So this is a 2 and this is a 3. And then let's see, what else? And then we can change this into a 3 and this into a 2. So now we have a 3 and a 3. So if we cross this one out, then we get 2 and 2. So that is just like one of the ways you could do it. It says that there are still other ways you could do it. So anyways, I'll leave that up to you guys to think about it on your own.